In this problem, we'll be determining the ultimate moment carrying capacity. So we'll first of all write down a problem. So problem is to determine the ultimate moment capacity. Ultimate moment capacity of the doubly reinforced beam of width, that is B, is equal to 350 mm. Cover, that is D dash, is equal to 60 mm. Effective depth is equal to 600 mm. AST is equal to 2945 mm square. There is 6 numbers, 25 mm diameter bars, and ASC is also given, that is area of compression reinforcement 1256 mm square. 4 numbers, 20 mm diameter bar, and we need to use M20 grade of concrete and Fe415 grade of steel. So that's the problem. Now we'll move ahead with the solution. First of all, we'll be checking whether the beam is under reinforced or the over reinforced, and then we will determine the moment carrying capacity of the beam as well as what is the limiting carrying capacity of the AST. Then we'll calculate the AST2 as well as ASC, and once we got that, and we will check what is the additional moment required and AST. And from that we will check whether it is sufficient or not. So we'll first of all go ahead with the solution step number 1. So solution, that is step number 1, to check if the beam is under reinforced or over reinforced. So that is the thing we will do first of all. So now first we'll go ahead with the calculation of axiom max. So here axiom max is equal to axiom max by D ratio, that is 0.48 for M20 and Fe415, and therefore you can calculate axiom max, which is equals to 0.48 multiplied by D. Small d is already given, that is 600 mm. So 0.48 multiplied by 600, you will get it around 288 mm. And then we'll calculate the yield strain, that is epsilon st, and that is equals to epsilon c into d minus epsilon max divided by x max. So this is the formula. So we'll first of all calculate strain, tensile strain, that is epsilon st, which is equals to compression strain into d minus xu max divided by xu max. So this is a direct formula which we have just considered from a book. We will get it from any book. And now here strain in the compression, that is maximum strain in the compression, that is 0.0035. D you got here 600 mm minus xu max, that is 288, and this is divided by xu max, that is 288. Now if you solve this, you will get, therefore epsilon st would be equals to 0.00379. Now you can go ahead with the calculation of yield strain of Fe415. Now yield strain of Fe415, which is already given in IS code, as well as you can just keep and remember 5 divided by 1.15 ES modulus of elasticity of the, that is for 415, and then 0.002. So this is equals to 415 divided by 1.15 modulus of elasticity for steel, that is 2 into 10 raised to the power 5 plus 0.002. I need to check what is the value you are getting here. So this value is coming out to be 0.0038. Now this is greater than 0.00379. Just simply it is greater, and therefore we can say this beam is over reinforced. Therefore the beam is over reinforced. So the beam is over reinforced, this is what we get. And now the next thing is to determine mu limiting and then AST limiting. So that will be step number 2. So step number 2 is to determine mu limiting and AST limiting. So we need to use the equation. So we can get the equation on this page number 96. This is the equation. Mu limiting is equals to 0.36 x max by d into 1 minus 0.42 x max by d to bd square fck. This formula we can use. So clause G1.1c, page 96 of IS 456. So we got the formula, mu limiting equals to 0.36 x u max s. Now instead of this is x u max by d into 1 minus 0.42 x u max by d bd square fck. So this is going to be 0.36, as you know, x max by d for M20 and F415, that is 0.48. So 1 minus 0.42 into 0.48. Width is already given, that is 350 mm. Effective depth is also given, that is 600 mm multiplied by 20, that is fck. So if you solve this, you will get limiting carrying capacity for this beam according to the width and the depth of the beam as well as axis limiting. So you will get this value as 347.67 kilonewton meter. So you should remember how exactly we have written here. Now we can calculate in the next line for, let us say, for FCK, which is equals to 20 Newton per mm square, and Fy, which is equals to 415 Newton per mm square. So you got here AST limiting, that is the limiting percentage of area of steel, that is 0.96. So 0.96 multiplied by B into D. So this is 0.96 multiplied by 350 multiplied by 600. So you will get this around 2016 mm square. Now we'll go ahead with this calculation of step number 3. So step number 3, that is to determine AST2 and ASC. So AST2, which is actually, we are going to use the formula again from the same page number 96. We got here AST, total AST equals to AST1 plus AST2. So we can calculate here AST2 from here, and then we also need to calculate area of compression steel. So that is ASC. So ASC we will calculate. In terms of AST2, that is also here AST2 equals to ASC into FSC by 0.87 F5. With the help of this formula, we can again calculate ASC here. So again, write down from clause G1, page 96 of IS 456. So we'll be getting here AST2, and that is equals to AST minus AST limiting carrying capacity. So this is equals to 2945, which already given, minus AST limiting, just now we have calculated. So this is going to be around 929 mm square. Now we know that ASC is equal to AST2 into 0.87 Fy divided by FSC minus FCC. We just deduct FCC from there as well. So this AST2 you got 929 into 0.874 multiplied by 415, and this divided by FSC. This, as I already told you, you can just consider around 350 minus FCC, this, that is 0.446 into 20, which we have seen earlier cases. Now if you calculate this, you will get around 978 mm square. That's your area of compression reinforcement. Now we'll move toward the step number 4. So step number 4, which is to determine MU2, MU and AST. So this is to be determined. So again, we have seen in the same page number 96. So from page number 96 we'll get mu2, which is equals to ASC into FSC minus FCC into D minus D dash. So SC got 978 multiplied by 350 minus 0.446 into 20. D already known, 600 minus covers D dash. So if you calculate this, you will get around 181.12 kilonewton meter. So that is the mu2. Now if you just add mu limiting and mu2, you will get the total mu. So therefore now mu equals to mu limiting plus mu2. mu limiting we already calculated, that is 347.67 plus 181.12. So this is the total mu. You will get around 528.79 kilonewton meter. So that is the mu you got, 528.79, and we can again calculate AST as well. That is the ultimate moment carrying capacity. Now we can even calculate AST total, which is equals to AST limiting plus AST2. This is going to be 2016 plus 929. So you will get around 2945 mm square. So that's the total AST. This is what required in the problem.